In this video, we'll be discussing specific questions in CBSE, in the CBSE board exam paper for the year 2020, and it's specifically for set 1. First of all, I got this paper through the IITN Academy or from iitnacademy.com. They have papers with the solutions, so they have it for different subjects. You can go check it out, and I will have the link in the description below. So I thought it would be a good idea for us to have specific videos targeting, chemical reactions, because you have 5 chapters to 6 chapters, just organic chemistry. So at one point when I was in grade 12, I found it extremely difficult. So I thought it'll be a good idea to have a series of videos having those questions. So the first one, so this is like the paragraph that you have to read, and then you have to answer a couple of questions. So I'm going to just jump right into this question. That is the third one. That is, predict the major product formed when 2-bromopentane reacts with alcoholic KOH. So let's first draw the structure. This question number, Okay. So this is question number 3. You have 2-bromopentane, which is CH3, CH. Always, whenever I write a structure, I just go over it once to check if all the valencies are met for carbon atom. So when this reacts with alcoholic KOH, since it's, first of all, this is a secondary alkyl halide. Okay, and when it reacts with alcoholic KOH, it does not undergo a substitution reaction. On the contrary, it undergoes a elimination reaction. So over here we have the possibility of 2 products being formed, right? So here you can have the bromine and the hydrogen. So this and one of the hydrogens, or this and one of this, because you have a beta elimination reaction. I'm sure you know about that by now. So when you have such a reaction taking place, you have the elimination of a HBr molecule. So you have 2 possibilities: CH2 double bond, CH single bond, CH2, CH3. 1, 2. Okay, wait, I decreased. Sorry, this is supposed to be a CH2 and then a CH3. So we have this product, and then we also have another product that's possible, that is CH3, CH, double bond, CH, CH2, CH2, okay, CH3 rather. Okay, so we have 2 products, and notice over here they've asked specifically for a major product that is formed over here. Okay, so according to the Seitzeff's rule, the more alkylated a particular alkene is, that is considered to be the more preferred of the lot. And because of that particular rule, we have this one as the major product. And you just have to mention that this is the product. I mean, you don't even have to write the chemical reaction. It's just, it makes sense for me to explain it with the chemical reaction that I tell you. So this is going to be our major product. And we also have KBr and H2O. So this particular question obviously is from haloalkanes and haloarenes. The next question is, we are supposed to write the structures of the products formed when anisole is treated with HI. So question number 5. And first of all, anisole structure is benzene with an OCH3 group. Now, when this reacts with HI, what is the product formed? Now, this particular reaction, if you can find it in alcohols, phenols, and ethers, and specifically the chemical reactions of ethers. So when an ether reacts with, or when, let's say, you have a benzene substituted ether, or one of the R groups of an ether is a benzene ring, and this reacts with HX, where X is a halogen atom, we get OH, that is phenol, and RX. Using this particular equation over here, you have HI. Okay, and then the product is going to be phenol in both the cases, but the CH3, the other product is going to be CH3I. And this is, again, this is from alcohols, phenols, and ethers, and that's the chemical reactions of that particular, of ethers specifically. The next one is question number 26. Question number 26, here you have propanone is treated. So what happens when propanone is treated with methyl magnesium iodide and then hydrolyzed? So we've been given a question where you have a specific compound reacting with the other one, and we need to understand, or we need to figure out what the chemical reaction is. So ideally, it would just make sense to talk about it in terms of chemical reactions, and it's actually from alcohols, phenols, and ethers, and not aldehydes, ketones, and carboxylic acids. So CH3, CH2. Oh, sorry. Propanone, that is CH3CO, CH3. So when this reacts with methyl magnesium iodide, methyl magnesium iodide is actually, first let me write it, CH3MgI. If it looks familiar by now, I'm pretty sure you figured out what the chemical reaction is about. So this is actually the Grignard's reagent. And this reaction is for the preparation of alcohol using the aldehyde, but they use the Grignard's reagent. So let me just quickly put the general chemical reaction where you have, let's say we have a carbonyl compound, and this is reacting with a Grignard's reagent. And since the magnesium has a partial positive charge, this having a partial negative charge, this will come and attack this. You have a shift of this, and then this leads to the formation of our adduct. Now, this, on the other hand, is again, oxygen has a minus charge, magnesium has a positive charge, then you have an X. And this undergoes hydrolysis for us to get alcohol. OH plus Mg, okay. MgOH X. So this is our general Grignard's reagent. And here they've mentioned that it is not only getting treated with the methyl magnesium iodide, but it is also being hydrolyzed. So basically they want this product, whatever is formed over here. This is the product that they want. So when our our ketone is reacting with methyl magnesium iodide and getting hydrolyzed, we will get an alcohol. And since this is a ketone, we will get a secondary, or yeah, sorry, you will get a tertiary alcohol. So CH3, COH, CH3, and another CH3, and the byproduct is going to be MgOHI. So this is the product that is formed. The next one is benzene is getting treated with CH3COCl with anhydrous AlCl3. Usually when we see the word anhydrous AlCl3, it's obvious the type of reaction they're talking about, that is the Friedel-Crafts reaction. And since it's a COCl, it's a Friedel-Crafts acylation reaction. So basically you have benzene undergoing a chemical reaction with CH3CO, Cl. And the only reason I was able to remember this at this point was because I did a video about the various named reactions. And if you're interested, you should totally check it out. So anhydrous AlCl3. So when you have this reaction take place, I'm pretty sure if you remember what the Friedel-Crafts reaction is, you would know the product. So we get this particular type of product. And this is basically also this is in the chapter aldehydes, ketones, and carboxylic acids. And it is under the preparation of ketones from benzene or substituted benzene, which is a Friedel-Crafts reaction, and specifically an acylation reaction. The next one is we are supposed to give the structures of A and B in the following sequence of reactions. But before that, I'm just going to quickly erase some parts of all of this because I'm running out of space. But honestly, I found it's easier to, just go through all the chemical reactions, and instead of trying to by heart them or learn them or memorize them, it makes your life much easier if you understood them and then tried and practiced these questions. That'll just help a lot. Okay, now let's start with question number 28. Now, we are supposed to give the structures of A and B in the following sequence of reactions. And for such reactions, what I would do personally is I'm going to go about it as one reaction at a time. Okay, so let's start with A. Now, the first one is acetic acid. So CH3COOH is undergoing a reaction in the presence of NH3 and heat. Okay, now when this happens, basically, this is from, again, aldehydes, ketones, and carboxylic acids. And this is the reaction of carboxylic acid with ammonia. So when I'm going to write the whole reaction, obviously over here, so CH3COOH undergoes a chemical reaction with ammonia, that is NH3, to give us this beautiful product, which is CH3, COO minus and an NH4 plus. So the easiest way to remember is the hydrogen gets kicked out from COO and it gets attached to the NH3 to form NH4 plus, obviously because the valencies, and O wants another bond, so it's having a negative charge. And this is called as ammonium acetate. Now, when this undergoes heating, or when this is heated, there is an elimination of a water molecule. And because of that, you have the product CH3CONH2. That is an amide. So this is going to be A. So we figure out what A is because they've told both ammonia as well as heat. If it had just been ammonia, then we would have to probably stop over here. But since they mentioned that it has been heated, the product is going to be CH3CONH2. And this is A. Now, this is undergoing a chemical reaction with NaOBr. Okay, honestly, when I was searching for this particular one, I found it so difficult to find the answer. And then I got to know this amazing piece of information that NaOH, when reacts with Br2, it is going to give us NaOBr. And if you figure out that bit by now, this is actually the Hoffman's bromamide reaction. And fun fact, this whole question is in your textbook. Like it's there in the textbook questions. So when you have a Hoffman bromamide reaction, the one which has been given in your textbook is RCO, that is an amide, is reacting with bromine and sodium hydroxide, which gives us NaOBr. I spent half an hour with this question. So because so my aim for this particular thing was to figure out if I could solve all the questions on my own using the textbooks alone, obviously. And yeah, in this question, I just had to look it up. So plus 2H2O. So then basically this is the general reaction for Hoffman bromamide, and it's obvious that one of the major products that we get out of this reaction is an amine. And one of the carbon atoms, this carbon atom is going to get kicked out, and you have a CH3 and H2. That's it. So the product is CH3 and H2. This is our B. So for the exam, you do not have to mention all of this. It's just that I would like to give you more clarity and more, for it to make more sense that I'm writing all of this. The next question over here is we have, let me just quickly erase all of this. But yeah, I found it really funny that I did not figure that one out sooner. Okay, anyways, question B, that is C6H5NO2 reacts with iron and HCl. And usually for benzene reactions. I prefer to write the benzene ring itself as opposed to using C6H5. I don't know why. You can do C6H5. That's again a personal choice, but I like drawing the benzene ring. I think so many years of organic chemistry has done that to me. So this undergoes a chemical reaction with Fe and HCl. So what happens when this happens? When this particular reaction takes place. So here, this particular point or this particular reaction is in the reduction of nitro compounds and specifically preparation of amines. So when the NO2, nitrobenzene reacts with Fe or Fe in the presence of HCl, it leads to the formation of NH2, which is aniline. And this is undergoing a reaction with NaNO2 and HCl at 0 degrees or 0 to 5 degrees Celsius. So NaNO2 plus HCl, 0 to 5 degrees Celsius. And this particular reaction leads to the formation of the benzene diazonium salt. So this is the preparation of the diazonium salt. And that's the formation rather. So N2 plus and Cl minus plus NaCl plus 2H2O. Now, fun fact is that, like in your textbook, they've given the temperature in Kelvin, but here in the exam, they've asked you in terms of Celsius. So, remember that, the relation between Kelvin and Celsius, and in the textbook, it was in the Kelvin scale, or here it is in the Celsius. That's one difference that I noticed. The last question is obviously N2 plus Cl minus is benzene diazonium salt. So I'm just going to draw that. And this is, I think, if I'm not wrong, that's a named reaction. If you can figure it out, do think about it. Pause the video, try answering this on your own. So this is undergoing a chemical reaction with CuCN and it's being heated. So this is actually the Sandmeyer's reaction, where you have just the CN getting substituted over here, or the CN is actually replacing the N2 and Cl. So our product is going to be a benzene ring with a CN group attached to it. And the byproduct of this reaction is nitrogen. And this is the Sandmeyer's reaction. Sandmeyer's reaction. Now, this particular compound is undergoing a chemical reaction with H2O, H plus. Now, this is actually in aldehydes, ketones, and carboxylic acids, and this is one of the methods of preparation of carboxylic acid from nitriles. So when this happens, what will happen? Okay, that was a lot of happens, but what happens in this reaction is that the nitrogen is going to get kicked out and you're going to have OO and H added to it to give us a carboxylic acid. So if you notice, this question is essentially from two different chapters, where you have this from, if I'm not wrong, amines, whereas this from aldehydes, ketones, and carboxylic acids. So that we're done with question number 28. The next one is question number 37, and we're not talking specifically about question B of this because, we are talking about B because they're conversions. A, I'm pretty sure you can do it, and if not, I'm hoping I start uploading videos about those as well. But right now we're focusing on chemical reactions. 37. Question number B. Now we need to write the conversions. So for such questions, what I would do is write the reactant, write the product, and then figure out how we will get from A to B. So in this question, you have phenol, which is pretty straightforward. That is benzene with an OH group. And this has to get converted to salicylaldehyde. Salicylaldehyde, as the name suggests, has an aldehyde group. So it has an OH and a CHO. So this is salicylaldehyde. So this actually is a named reaction, Reimer-Tiemann reaction. I hope I'm pronouncing it correctly. So this is basically in this reaction, what we do is we have phenol undergoing a chemical reaction with CHCl3 chloroform and aqueous sodium hydroxide. And this leads to the formation of this particular intermediate where you have here the oxygen O minus. So since you have a sodium that happens, and then you have the CHCl2. I don't remember clearly, but I think when I was grade 12, I got this question in the exam. I mean, not this question about, but about Riemer-Diemen reaction. So this is the intermediate, and this undergoes a reaction with sodium hydroxide and leads to the conversion of the CHCl2 to an aldehydic group. So you have the formation of the CHO, but we still have O minus and Na plus. But according to our question, we need OH. And so we're going to kick the sodium ion out by having the H plus, and this leads to the formation of salicylaldehyde. So this is a pretty straightforward question where you just have to remember, okay, there is something called as Riemer-Diemen reaction where you have the conversion of phenol to salicylaldehyde. But maybe if you just saw the words phenol and salicylaldehyde, maybe you would have found it difficult to remember that. But if the moment you put the structures in, it would make things much easier because it's easier to remember visual stuff, at least for me it is. So the next one is I'm just going to write it over here. I'm scrolling up and down from now. Okay, tertiary butyl chloride to tertiary butyl ethyl ether. So let's first draw the tertiary butyl. So CH3, Cl, because you have chloride, tertiary butyl chloride, and this has to get converted to tertiary butyl ethyl ether. So you have a CH3, CH3, CH3O, CH2, CH3. First of all, the immediate reaction that we think about when we look at this conversion is the Williamson synthesis, and we would just take the RX, this as the RX group, so CH3C, the tertiary chloride, and then on reaction with this would probably get react with CH3, CH2, ONA, and this in turn would give us a product. But unfortunately, Williamson's ether synthesis cannot be used when your your halide is a tertiary halide. When you have this and when you do this particular reaction, we will not get this. Instead, we will get a double bonded group. So the product in this case would be CH3, C double bond, CH2, basically an alkene, CH3 plus NABR plus CH3COOH. And this is, honestly, when I was solving this question, I thought about this and I directly did this. And I got this product, obviously, I was trying to write. And then I realized that when you have a tertiary alkyl halide, you cannot do this particular reaction. So we need to figure out a way to convert this chlorine to something else that will give us this ONA group. We're still going to be using the Williamson ether synthesis. So how do we convert the Cl to an OH? Again, this particular reaction is there in your textbook. So so this is in haloalkanes and haloarenes. So for ease, I'm just going to say CH3 thrice. CCl is reacting with sodium hydroxide to give us an alcohol. So CH3 thrice COH. So we've converted from a chlorine to an OH, from an halide to an hydroxy group. Now this reacts with Na plus, okay, or it reacts with sodium rather. Sorry, I shouldn't have written Na plus. So it reacts with sodium. And this in turn is going to give us a CH3 thrice. So the H will get kicked out, Na is going to get replaced over there. So CONA. Okay, and this is one of the reactants for the Williamson ether synthesis. So this can react with CH3, CH2, Cl. Okay, so Williamson ether synthesis is basically going to be Rx plus R dash ONA gives rise to R O R dash plus NaX. But because of the fact that if we have a tertiary alkyl halide, it will not undergo this particular reaction properly. We had to replace the Cl in the tertiary alkyl halide to the ONA group instead. So this in turn is going to give us the product that we wanted, that is CH3 taken thrice, COCH2, CH, V plus NaCl. I hope that makes sense. The next question is, okay, the next one is propene to propanol. Okay, that's pretty straightforward if you ask me. Again, with the structures, we're going to start with them. So CH3, CH, double bond CH2 is giving rise to propanol. And since they didn't mention 1, 2, or 3, or 1 or 2, we're going to have it at the end. So immediately after I saw this reaction, I assumed it's going to be a straightforward dehydration reaction, or acid catalyzed dehydration reaction. But then I realized when you have an acid catalyzed dehydration, because of the mechanism, the major product is going to be 2-propanol and not 1-propanol. So because of that, we will instead be using the hydroboration oxidation reaction. So you have propene reacting with HBH2 or HBH2 taken twice. And this in turn is going to give us CH3, CH, CH2, HBH2. And this further is undergoing a chemical reaction with another molecule of propene. And basically, you have the hydrogens of the boron being replaced by the alkyl group. So I'm supposed to write CH2, sorry. Twice BH. Then you have another molecule of propene. So CH3, CH, CH2. And this gives us CH3, CH2, CH2 taken thrice B. And this in turn is going to undergo a chemical reaction with, okay, that was extremely bad. So H2O and 3H2O2, hydrogen peroxide, and OH minus. And this is going to give us 3 molecules of CH3, CH2, CH2, OH plus BOH. So this particular reaction actually makes you think. Again, both the reactions, actually the previous one also had to make, we had to think for a bit and then solve it, but it's pretty easy. It's just that we assume that it's one thing. We just need to think about the other possibilities as well. So the next one is giving the OR question, that is, A, give the mechanism for the formation of ethanol from ethene. This is a basic reaction where you have the dehydration of alcohol to give us the alkene. The mechanism is in the textbook, and also do check out the video that I did just for the mechanisms of this particular chapter. So one of the mechanism was the dehydration reaction as well. So do check it out. The next one is B, predict the reagent for carrying out the following conversions. So the first one is phenol to benzoquinone. Now, phenol to benzoquinone, again, we're going to be writing the reactants of the products. So phenol is giving rise to benzoquinone. So how is this particular reaction happening? It's actually a very straightforward reaction where you have the oxidation of phenol, and this happens in the presence of sodium Na2ErO2 And this is a direct, sorry, Cr2, Na2Cr2O7 and H2SO4. These two reagents are used for the conversion of phenol to benzoquinone. It's a direct reaction in your textbook. You just need to remember that this particular reaction exists. The next one is anisole to para-bromo-anisole. This is again another easy one. Uh, so anisole is benzene with an OCH3 group. Now this is giving us para-bromo-anisole. So we know what are OCH3, ortho, meta, and para. So we have bromine in the para position. Now this is a direct electrophilic substitution reaction. So we use bromine in acetic acid to give us this product. So generally you would expect two products to be formed. That is the ortho and para positions get substituted because OCH3 is an ortho para dielectric group due to the lone pair of electrons on the oxygen atom. But para position is the preferred product, or the para is the major product due to steric reasons. And bromine in CH3COOH is how this particular reaction takes place. The last question for this paper is phenol to 2,4,6-tribromophenol. This is again another straightforward electrophilic substitution reaction. And all these three questions were from the chapter alcohols, phenols, and ethers. So we have phenol, and this is a reactant, and the product is two, four, six tribromophenol. Now, this happens in the presence of three bromine molecules. So just 3Br2. So when this reacts with 3Br2 in the aqueous medium, this leads to the formation of basically bromine in water. That is what this is. And this gives us 2,4,6-tribromophenol, which is a white precipitate. With that, we're done with the set one. I hope you understood this. I hope it helps. Do check out the other videos on the mechanisms, and that's all for now.